Hello Math Fanatics, I'm Mathematics and this is the 2010 AIME I Problem number 6. Before the video begins, make sure you have a solid understanding of polynomials, inequalities, and quadratic equations. But even if you don't, that's okay. Keep watching the video and let me know down in the comment section below what you want to know next. Alright, so the problem states, let p of x be a quadratic polynomial with real coefficients satisfying x squared minus 2x plus 2 is less than or equal to p of x, which is less than or equal to 2x squared minus 4x plus 3 for all real numbers x. And suppose p of 11 is equal to 181. Find p of 16. Alright, so that was a really wordy problem, especially with the amount of symbols it had. Let's break this down. First, we know that p of x is a quadratic polynomial because the problem gives us that. And also, it's got real coefficients, which is going to be helpful. Now we know we have this inequality here, which is quite straightforward, but it can be a little hard to understand. All it's saying is that p of x is greater than this and is less than this. And it satisfies that for all real numbers x. That's going to be key too. Now they're saying that p of 11 is going to be equal to 181, and they're asking us to find p of 16. Alright, so the first thing you want to do with most polynomial problems is just try and plug in some values, especially when it's as easy to plug in values as this. So let's see, when x equals 0, so when x equals 0, then we've got right here, that's 0, so it's going to be 2 right there is less than or equal to p of 0, which is less than or equal to, again, that's 0, 3. So when x is 0, 2 is less than or equal to p of 0 is less than or equal to 3. Great. What about when x equals 1? When x equals 1, we've got here 2, we've got here 1, and then we've got negative 2, that's going to be negative 1, and plus 2, that's going to be 1. So we've got 1 is less than or equal to p of 1, which is less than or equal to, and then 2 minus 4, which is negative 2, plus 3 is 1. Okay, so what this means here, this implies that p of 1 equals 1. And that's because 1 is less than or equal to p of 1 is less than or equal to 1. How else can you have it? If p of 1 is greater than 1, then it's not less than or equal to 1. And if it's less than 1, then it's not greater than or equal to 1. So it's got to be 1. And finally, let's plug in 2. So when x equals 2, we've got here, this is 4 minus 4, that's 0. This is 2. Is less than or equal to, here this is 8 minus 8 is 0, 3. So we've got 2 is less than or equal to p of 2 is less than or equal to 3. Alright, so what can we see here? Well, one thing to remember is that in a quadratic, when the quadratic is decreasing and then switches to increasing, that's going to be the minimum value of the quadratic. And that's going to be the center of reflection. What I mean by that is, if we look at the shape of a quadratic, specifically one that opens upwards, it'll look something like this. And you'll notice the value of y is decreasing and decreasing and decreasing and decreasing, and suddenly it gets increasing and increasing and increasing. Now that switch from decreasing here to increasing only happens at one spot, and that's at the base, right there, that's at the base of the polynomial, or rather quadratic. Now this only applies to quadratics, because quadratics only have one curve. Alright, so we know that x equals 1 is going to be the base, or the vertex, of the polynomial. Well, we also know here that p of 11 equals 181. So let's, for the time being, say that right here, this is 11. Sorry. This is 11, and this is 1. So this is 11. Then let's see, what other values in this polynomial are 181. So obviously when x is 11, it's 181. Now the only other spot that we can see is going to be directly across from it right here. Now what is this point? Remember I mentioned earlier that 1 was the center of reflection, and I did mean that. If you reflect any point in the quadratic in the graph of the quadratic equation across this center of the line of reflection, it's going to reflect directly across onto the other side of the quadratic. That was confusing. All it means is the distance from this to this is also equal to the distance from this to this. So since this is 1 and this is 11, the distance from 11 to over here is going to be 10. And since from what I just said, that means that this is also going to be 10, which means that right here we're getting -9. So that means that p of 11 equals p of -9, which also equals 181. And that is really helpful. Alright, so let's take a new slide here and see what we can do with that. So first, let's rewrite this. Let's rewrite this right here. P of 11 is equal to P of -9 is equal to 181. So with this, let's try and see if we can get a similar polynomial here. In fact, let's look at the polynomial q of x, and let's say this polynomial is equal to p of x minus 181. Then we have q of 11 is going to equal q of 9 is going to equal 0. So 11 and, well, this is -9, sorry. 11 and -9 are the roots of q. So we can say that q of x, and this is going back to the definition of a polynomial, quadratic, q of x is equal to a times x minus 11 times x plus 9. Alright, great. Now we know if we can just find a, then we can find q of x, which means we can find p of x. We can find q of x, then we can find p of x. So all we need to do is find a. How can we do that? Well, let's go back here to this slide. Over here, we found that when x equals 1, p of 1 equals 1. So we've got one more value that we can try and plug in. So let's try and do that. So here we have, well, q of 1 equals p of 1 minus 181. So let's set these two equal. We've got a of x minus 11 into x plus 9 equals p of x minus 181. So now plugging in x equals 1, we get a times 1 minus 11 is -10 times 10 equals 1 minus 181, which is going to be negative 180. So that means that a is going to then equal 180 over 100, which is 1.8. Amazing! We have found a. So now all we need to do is plug in a to find q of x, and then use that to find p of x. So let's do that. We know that q of x equals 1.8 times x minus 11 times x plus 9. Q of x, and let's write that down here, q of x equals 1.8 times x minus 11 times x plus 9. So that means that p of x, and just to be clear, I have taken this right here and I have plugged that straight into there. And so we will take that and we'll say p of x is then going to equal 1.8 times x minus 11 times x plus 9 plus 181. And remember, that's because we're going to take this and put it on that side, so the way we do that is by adding 181 to both sides. We're going to add 181 here, and we're going to add 181 here. So now, all that remains to do is actually plug in p of 16. Alright, so we have p of 16 is going to equal 1.8 times 16 minus 11 times 16 plus 9 plus 181. So that's going to equal 1.8 times 16 minus 11 is 5 times 16 plus 9 is 25 plus 181. Now 1.8 times 5, that's going to be 9. So this is going to equal 9 times 25 plus 181. 9 times 25 is 225, so this is going to equal 225 plus 181, and that is going to equal 406, which is our answer. Alright, so thank you all so much for watching. Please don't forget to like and subscribe, and I will catch you all in another video.